In this video, we are going to talk about how to find the indefinite integral using trigonometric substitution. Now, there are three forms that we need to be familiar with. The first one is if the given integrand involves square root of a squared minus u squared, you replace u with a sine theta, where a is a constant. And the reason for this is that 1 minus sine squared is equal to cosine squared. Now the next form is the square root of a squared plus u squared. We replace u with a tangent theta. And the reason for this is that 1 plus tangent squared is equal to secant squared. And the last one, so when the given integrand involves the square root of u squared minus a squared, we replace u with a secant theta. Since we know that secant squared minus 1 is equal to tangent squared. Again, these are the forms that we need to look into when using trigonometric substitution. Now let's solve some problems. Okay, first one. So we integrate dx over the square root of 4 plus x squared. So how can we integrate this function? Notice that we have the form a squared plus u squared, or the square root of a squared plus u squared. So we then use the substitution u equal to a tangent theta. So we can clearly see that a squared is equal to 4. So to find for a, we get the square root of both sides. We have a equal to 2. You can also see that u is x is equal to x. So we replace now x with a tangent theta, where a is equal to 2. So that will be replaced with 2 tangent theta. Now we differentiate x equal to 2 tangent theta, since we need to replace dx to differentiate tangent theta, and that is secant squared theta d theta. Now we have the integral of dx, which is equal to 2 secant squared theta d theta over the square root of 4 plus x squared, but x is equal to 2 tangent theta. So we have 2 tangent theta raised to 2. Okay, so let's continue. Now, simplifying the given function we have, so we copy 2 secant squared theta d theta, and we know that 2 tangent theta raised to 2 is equal to 4 tangent squared theta. You can see that there is 4 in each term here in this part of the integrand in the denominator. So we factor out 4. Factoring out 4, we have 4 times 1 plus tangent squared theta. So as you notice, 1 plus tangent squared theta is equal to secant squared theta. So now we replace this 1 plus tangent squared theta by this identity secant squared theta, okay, inside the squared symbol. Now we take the square root of 4 secant squared theta, and we have now 2 secant theta. So you can see that there's a secant in the numerator too, so we can cancel that. We can also cancel 2, giving us the integral of secant theta d theta. Now we have a formula for this, and the answer to the integral of secant theta d theta is the ln of secant theta plus tangent theta plus c. Now this is the final answer, but with not the real or not the original variables. Okay, so we need to change theta back to the original variable, which is the x variable. So how do we do that? Okay, going back to our substitution, we know that x is equal to 2 tangent theta. So dividing both sides by 2, we have tangent theta equal to x over 2. So we now utilize the triangle. Okay. But first, you need to be familiar with the principle of SOHCAHTOA. So still, you need to recall this. So means sine is equal to the opposite over a hypotenuse. This one is cosine equal to adjacent side over the hypotenuse. And this TOA means tangent is equal to the opposite over the adjacent. CHOSHAKA, on the other hand, is the reciprocal of this one. So for CHO, we have cosecant is equal to hypotenuse over the opposite side. SHA means secant is equal to hypotenuse over the adjacent side. And COW means cotangent is equal to adjacent over the hypotenuse side. Okay, so now let's draw the triangle. So we have the right triangle where our theta is here. So we use this equation, tangent theta is equal to x over 2. So tangent means opposite over the adjacent side. So opposite side is x. So you write x here. And the adjacent side is 2. So we put 2 here in this part. So how to determine the hypotenuse? So do we need this part? So take a look at the final answer. We have secant and tangent. So secant, we need the hypotenuse. So that's why we have to determine this part of the right triangle. So remember the Pythagorean theorem. So the square of the hypotenuse, for right triangle, the square of the hypotenuse is equal to the sum of the squares of the sides. So we have, this is c, so c squared is equal to a squared plus b squared. So to find for this side, so we need to take the square root. And that is, so square of this, so 2 squared is 4, and x raised to 2 is x squared. So we have hypotenuse equal to the square root of 4 plus x squared. Now going back to this answer, we need to replace theta by the original variable or by the x variable. So from this right triangle, we can say that the ln of secant theta plus tangent theta plus c is equal to, so secant theta means hypotenuse over the adjacent. So hypotenuse is the square root of 4 plus x squared. So you write here 4 plus x squared, or square root of 4 plus x squared over the adjacent side, which is 2. And then plus tangent theta is equal to x over 2. So we write x over 2 here, and then plus c. Now we have the final answer for this integral. Now we move on to the next problem. So let's find the integral of dx over 4 minus x squared raised to 3 halves. So look at the given integrand. So we have this form, square root of a squared minus u squared in the given integrand. So we now use the substitution. So we replace the variable x by a sine theta. Okay, so, and we can see clearly that a squared is equal to 4. So by taking the square root of this equation, we have a equal to 2. Now for our u, so in the given integrand, we have the variable x representing for this integrand. So we have the variable x. So we replace x by a sine theta, where a is equal to 2 times sine theta. Of course, we need to replace dx, so we have to differentiate this. So we have dx is equal to 2 differentiate sine theta, we have cosine theta d theta. Now you plug in these values here. Dx is equal to 2 cosine theta d theta over 4 minus x squared. X is equal to 2 sine theta. So you put 2 sine theta here raised to 2. And then put a bracket, raise the entire function here to 3 halves. Okay, moving on. We copy first. So we can see that 4 is common in the denominator. So we can factor out 4. We can rewrite the given function in the denominator. So 4 times 1 minus sine squared theta. And as you can see, we have 1 minus sine squared theta. So this is equal to cosine squared theta. So we rewrite. We can also replace 4 by 2 squared to simplify this given function. So 2 squared raised to 3 halves times cosine squared theta raised to 3 halves. So we can cancel. So 2 squared raised to 3 halves is actually, we can do this, we can cancel the power 2, giving us 2 cosine theta d theta over 2 cubed times cosine cube theta. Now, as you can see, there's a familiar function in the numerator. Okay, the same with that in the denominator. So we can cancel cosine theta. So cosine theta will be canceled, and of course 2 will be canceled. That's why we have 1 over 2 squared is 4. So we have 1/4 times the integral of, so we put 1/4 before the integral symbol because it's constant. Now we have the integral of d theta over cosine squared theta. And we know that 1 over cosine squared theta is equal to secant squared theta. So we have this one, 1/4 times the integral of secant squared theta. Again, there is an answer to this. So we have the formula. Integral of secant squared theta d theta is equal to tangent theta. So you just copy the constants. We have 1/4 tangent theta plus c. Now this is the final answer. This is the final answer, but not of the appropriate variable. Means that theta is not the original variable. So we have to bring back the original variable. We should replace theta by the x variable. That's why the importance of the triangle has to do this step. So we use the substitution, x equal to 2 sine theta from the beginning, and dividing both sides by 2, can clearly say that sine theta is equal to x over 2. Now we draw the triangle, and then of course we need to recall the principle of SOHCAHTOA. So draw the right triangle, so that our theta is here. So sine theta means opposite over hypotenuse. So this variable in the numerator is the opposite side, and this constant in the denominator is the hypotenuse. So we write here, we have opposite over the hypotenuse. So that's it. But in our final answer, we have tangent theta. Tangent is opposite over the adjacent. So we need this part of the triangle. So you have to solve for this using these values of the sides. So again, using the Pythagorean theorem, the principle of Pythagorean theorem, wherein the square of the hypotenuse is equal to the sum of the squares of the sides. So this part here is equal to hypotenuse squared. So that's 4 minus the square of this opposite side, which is x squared, and then take the square root of both sides. So we have square root of 4 minus x squared. Now, we have the final answer. So from the right triangle, so we have 1/4 tangent theta is equal to, so to replace theta, we need to utilize this triangle here using the principle of SOHCAHTOA. Opposite over adjacent is equal to tangent. So x over the square root of 4 minus x squared. So this is now our final answer. So you don't forget to put the plus c, or the arbitrary constant, since we are finding for the indefinite integral. Okay, so we have the last example. Okay, let's find the integral of the square root of 4x squared minus 9 times dx. So again, this is a familiar form wherein we have in the integrand the form u squared minus a squared. So we need to replace u by this trigo function a secant theta, where a is a constant. So this integrand is really of the form u squared minus a squared. But we have the variable x here in the given problem. So again, we have a squared, which is here equal to 9. So to find for the value of a, we take the square root of both sides. So we have a equal to 3. And for our u, which is in this part, so take the square root of this. So we have 2x to find for the value of u. So 2x will be replaced by a secant theta. That's why we have 3, the value of a, times secant theta. So we need to also replace dx by finding a differential, or the derivative of this. So we have 2dx equal to 3 times secant theta tangent theta d theta. This is the derivative of 3 secant theta. Okay, so to replace dx, we divide both sides by 2. We have dx equal to 3 halves secant theta tangent theta times d theta. Now we plug in the integrand. So we have this, the integral of square root of, so we have here 2x will be replaced by 3 secant theta squared minus 9 times dx equal to 3 halves secant theta times tangent theta d theta. Okay, let's continue. So we put this constant in front of the integral symbol. So, and then we simplify this. Now we can see 9 is common inside the squared symbol. So we factor out 9. So we have secant squared theta minus 1. And this is equal to tangent squared theta. Now we take the square root of 9 times tangent squared theta. We have 3 tangent theta times secant theta times tangent theta d theta. Now we combine them, we have, okay, so 3 times 3, we have 9. So we have 9 over 2 before the integral symbol. So all the constants are being put in front of the integral symbol. So we have tangent times tangent is tangent squared. So times secant theta d theta. And now we integrate this given function. We know that tangent squared theta is equal to secant squared theta minus 1. So we distribute this secant theta inside this function. So we have secant cube theta d theta. So we copy the constant, distribute this. So minus 9 over 2 times in the integral of secant theta d theta. So in the first term, you can see that this can be solved by integration by parts. I'll be showing to you the solution, but I will not be explaining to you anymore how to integrate using the technique integration by parts. So this is how we determine the integral of secant cube. Okay, so this is theta, but in here, our solution, we have utilized x. So the integral of secant cube x dx is equal to 1/2 the product of secant and tangent plus 1/2 the ln of secant plus tangent. So we utilize this formula here. So the integral of the first term, utilizing integration by parts, is we have 1/2 secant theta tangent theta plus 1/2 the ln of secant theta plus tangent theta. Okay, minus the second term is the integral of secant theta. So we simply copy the constant 9 over 2, and the integral of secant theta d theta is ln of secant theta plus tangent theta. So we put plus c. But this is not our final answer since theta is not the original variable. So we need to bring back the variable x. But before that, we need to simplify this since we can see similar terms. So we can see ln, secant theta, tangent theta, and also in the last term. We distribute first the constant here. So 9 halves times 1 half is 9 over 4. The same here in the second term. So 9 halves times 1 half is 9 over 4. That's why we have, on the first term, we have 9 over 4 secant theta tangent theta. So 9 halves times 1 half is 9 over 4 times ln secant theta tangent theta. Then you subtract 9 halves ln of secant theta plus tangent theta here. So we have minus 9 over 4 ln of secant theta plus tangent theta. Now we have two terms in our answer, okay, excluding the arbitrary constant here. Okay, so now we go back to, we need to bring back or to change the variable theta to variable x, and that is through, okay, using our substitution. So we have used 2x equal to 3 secant theta. So we have to draw a triangle again later. That's the idea here. So we always draw a triangle for us to be able to determine the value of secant and tangent. So here, 2x equal to 3 secant theta. So we divide both sides by 3. We have secant theta equal to 2x over 3. Okay, again, the principle of Sokotowa or Choshakao, since we have secant theta as the function here. So secant means hypotenuse over the adjacent. So this numerator is the hypotenuse and this is the adjacent side. Now we draw the right triangle. So this is our theta. We have the hypotenuse, so 2x. So this part is 2x. And the adjacent side is equal to 3. So we need to know this opposite side since we have tangent in our answer. So how do we determine that? So the square root of the square of the hypotenuse minus the square of the adjacent side. So we have 2x raised to 2 is 4x squared minus the square of this is 9. So we have the square root of 4x squared minus 9. Okay, so going back to writing our final answer, we have from the right triangle 9 over 4 times secant theta, which is 2x over 3. So we plug it in here. Tangent theta is opposite side over the adjacent. So we have the square root of 4x squared minus 9 over 3. So this is it. Now minus, the second term is 9 over 4 ln of secant theta. Again, this is 2x over 3 plus tangent theta is 4x squared minus 9 over the adjacent side, which is 3, and then plus c. Now we simplify, since we can see here 3 times 3 is 9, so we can cancel 9. And then 2 over 4 is actually equal to 1/2. That's why our final answer will be 1/2 x times square root of 4x squared minus 9 minus 9 over 4 ln of 2x over 3 plus the square root of 4x squared minus 9 over 3. Or you can combine this into one fraction, or you can simply write your final answer in this form. So that's all. If you have any questions, just comment down below. And I hope you learned something. And don't forget to like and subscribe. Thank you.